Hello, my name is Luke Capaldi. I'm one of the authors of Time-Dependent Knotting of Agitated Chains, and I'm also one of the contributors to WhyKnot. So this is just a short video tutorial to help new users get WhyKnot running on their system, and also to explain some of the functionality. Now, the source code can be obtained from GitHub here. The main repository is xcapaldi/WhyKnot, and you just need to confirm that you have all of the dependencies listed in the installation section with a README installed, in addition to WhyKnot ID. And after that, you can just clone the repo as you would any other. And then execute WhyKnot.py as you would any other Python script. So on the right-hand side, there are a few options, just a simple help. You can also clear the screen after we've drawn something, so. And of course, you can quit the program with Q. And most likely, the first thing you'll want to do is either to open an existing CSV file or generate a new file. This will serve to store some of the data that is collected. Okay, and then by clicking in the canvas, which is the white region on the left, we can generate nodes, which are connected by line segments, as so. Now notice that when line segments cross, there is a visual indication, and by clicking on those crossings, we can change which line segment is on top, like so. And we can continue to create more and more complicated knots. And we see that on the right-hand side, we have a non-trivial knot because the Gauss code is displayed, and in fact, it is dynamically updated, so if we were to continue making modifications, then it will be represented on the right. And then we have a choice as to how we want to save this result. We can either just save it as is, as a knot. We can also save it as an unknot or as a too complex knot, which is helpful for cases where the knot that you've drawn is more complex than your analysis software is capable of handling. But in this case, we'll just save it as a regular knot. And we'll also save an equivalent version as an unknot and as a too complex knot for illustration. So there are now 3 entries in knots.csv. And we will now clear and quit. Now if we go into the directory where we stored this result, we can see that knots.csv contains 3 values per entry. It contains the Gauss code, the minimum crossing number, and the Alexander polynomial. So this is entry number 1, which was just the regular knot that we stored, the unknot, and then the too complex knot. Now, there is also the subdirectory knots.json, which contains only one JSON file for the regular knot that we stored, and that file contains the 3D coordinates for that knot. Okay, I hope this has been helpful. Thank you very much.